After doing a whole chapter on fractions, I want you to see what they look like and how they compare to decimals. Recall that a fraction is a portion of a whole divided into two parts. The selected pieces of the whole over the total number of pieces of that whole. In this case, we'll have one chosen over a total of 5 pieces. Now, we have vocabulary for that. We have words for these things. In this case, we call the selected pieces the numerator, and that goes over the total number of pieces, the denominator. In this case, the numerator would be 3 and the denominator would be 5. Got that? Now, let's not mix that up with our vocabulary regarding division, which is kind of what's going on in a fraction. In a basic division problem, such as 42 divided by 7 equals 6, we have names for these numbers. The number getting divided is the dividend. The one doing the dividing is the divisor. And the answer to a division problem is the quotient. Now you may see it like this, where we still have a dividend, the number getting divided, a divisor, the number doing the dividing, and an answer, the quotient. You may even see it as a fraction. In this case, the dividend we would call the numerator. The divisor, the guy doing the dividing, would be the denominator. The answer is still a quotient. Okay, but don't let this confuse you. If we want to write a fraction as a decimal, basically all we're going to do is do the division. We're going to divide the numerator by the denominator. That's all there is. Well, there can be a little bit of tricks to it, but let's take a look at some examples. To change 2/5 to a decimal number, we'll divide 2 by 5. Now we're going to have to add some zeros, and of course I need a decimal point, and the decimal point goes after the whole number of the dividend, 2. Now let's put it up top so we know where it'll go. And I'll do the division. 5 into 2 goes nonce, so let's continue on. 5 into 20 goes 4 times. So I multiply and subtract, and I could bring down the next digit, but I know it's all going to end up being zeros, so I have an answer. That was easy, wasn't it? Top divided by bottom. I shouldn't say 0.4. To read this properly, remember it's 4/10. Let's try another. Let's change 1/4 to a decimal. Once again, I'm going to divide top by bottom. I may need to add some zeros, and I need to add that decimal point. Now let's put the decimal point up where we know he's going to go in the answer, the quotient. And let's do the division. 4 doesn't go into 1, so let's try 4 into 10. 4 goes in twice. I'll multiply, subtract, and I'm not done yet. I can't have a remainder, so I'm going to bring down the next digit, which is a 0, and I'll check 4 into 20. It goes in 5 times, and I'll multiply 5 times 4 and subtract, and now I've got an answer. 1/4 is 25/100ths, or 0.25, but rather we'll say 25/100ths. And I bet you already knew that. Now crazy things can happen when we do division, and I want to show you. Let's look at changing 2/3 to a decimal. Same thing, 2 divided by 3, top divided by bottom. Add your zeros. Now there can be more zeros if we want, but we'll just start with 2, and we'll throw our decimal up there. Now 3 doesn't go into 2, does it? So you can put a 0 there or not, but let's continue on with 3 into 20. Now 3 goes into 20 6 times. I'll multiply and subtract, and I'll bring down the next digit. Now once again, 3 into 20 goes 6 times. 6 times 3 is 18 again, and I'll subtract. Now I don't have an even answer, so I continue on bringing down the next digit. I don't see a next digit, but there is another 0. And I'll try it again. 6 times 3 into 20, I'll multiply and subtract. Do you see that this is going to go on forever? So actually, the fraction 2/3 is going to be 0.66666666 forever. It never ends. So what do? We're going to represent this with what's called a repetand. We're going to put a bar over the digit or digits that repeat. And of course you see that the 6 is repeating. So 2/3 written as a repeating decimal is going to be 0.6 with a repetand over it. And that, believe it or not, is the answer.
That's all I can say. Sheer unadulterated brilliance.
Now it's not always one digit that gets repeated.
Do that again.
Let's look at 3/11ths. 3 divided by 11. We're going to put our zeros. I put a little more this time. And put your decimal point. 11 doesn't go into 3. So let's try it into 30. Goes in twice. 2 times 11 is 22. If I subtract, I get an 8, and I'll bring down the next digit. Now 11 into 80 goes 7 times. We got a different digit. 7 times 11 is 77. If I subtract, I get 3. Now, bring down the next digit, and 11 into 30, I know this, I've seen this before, goes 2 times. 2 times 11 is 22. Subtract, I remember an 8. Bring down the next 0, there is one, and 11 into 80 goes 7 times. Look up top. I can see that this isn't going to end either, but it's going to repeat in a different way.
To infinity and beyond.
2 and 7 are going to repeat. So, once again, I'm going to use the bar or the repetand over the numerals that repeat. And the answer will be 0.27 with a repetand over it.
Yes, indeed. Simply marvelous.
Pretty cool, huh? Well, you're going to have to practice it. Get to your homework. Dig in.